Hello guys, welcome to my video on the introduction of trig identities. And we're going to start from scratch. And basically, for me to look at any trig ratio, I have to look at a right angle triangle. So we have the adjacent side, we have the hypotenuse, and we have the opposite side. Good? So let us recall what our trig ratios say. We know that the sine of the angle, sine theta, is equal to the opposite side over the hypotenuse. The cosine of the angle, which is cos theta for short, is equal to the adjacent side over the hypotenuse. The tangent of the angle is equal to the opposite side over the adjacent side. So these are our basic trig ratios. But look at the tangent of the angle. And basically, for me to remember this, there's a simple mnemonic that most persons use, which we say is SOHCAHTOA. Alright, so this basically means that S is for sine, which is opposite over hypotenuse. C is for cosine, which is adjacent over hypotenuse, and tangent. And T is for tangent, which is opposite over adjacent. Now we're going to look carefully at my sine and my cosine. Now, what if I were to divide sine theta by the cosine of theta? This means I would end up having sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Now, when we divide, we multiply by the reciprocal, so I'm going to end up with opposite over hypotenuse multiplied by hypotenuse over adjacent. Now, what happens here? The hypotenuse will cancel out, so here we go. So we end up with opposite over adjacent. And we know opposite over adjacent is really tangent. So what we're saying here is that sine theta over cosine theta is equal to the tangent of theta. And that is our first trig identity here. There's a next set of ratio that we would like to introduce it to. And this includes secant, cosecant, and cotangent. Let us start with secant. Secant is normally shortened sec theta. And this is defined as the hypotenuse over the adjacent side. Now if you look carefully at secant theta, it is actually the reciprocal of cos theta, because cos or cosine theta is equal to adjacent over hypotenuse. So we can say that the secant of theta is equal to 1 over the cosine of theta. Look at cosecant theta, which is shortened cosec. Sometimes we use CSC. This is defined as the hypotenuse over the opposite side. And then again, the sine of theta is opposite over hypotenuse. So the cosecant of theta is actually 1 over the sine of theta. The cotangent, which is shortened cot theta, this is equal to adjacent over opposite. Now bear in mind that the tangent of the angle was equal to the opposite side over the adjacent side. So the cotangent of theta is equal to 1 over the tangent of theta. We had also proven that the tangent of theta is equal to the sine of theta over the cosine of theta. So this being the reciprocal, we can say that the cotangent of theta is equal to the cosine of theta over the sine of theta. And these are some very critical identities that we'll be using in proofs and also in solving equations. For my next proof, I'm going to employ the use of the unit circle. Now let us say this is my circle. This movement here would actually represent my x movement, and this movement here would represent my y movement. So based on Pythagoras, and this is a right angle triangle, so based on Pythagoras' theorem, we could say that x squared plus y squared is equal to 1. Alright, let us bring the angle into play now. Now if I find the cosine of theta, the cosine of theta is equal to x, or x over 1, which is still x. The sine of theta is equal to opposite over hypotenuse, so sine theta is equal to y. Now let us call this equation 2, equation 3, and equation 1. We can see that equation 1 has both x and y. So we could sub equation 2 and 3 into equation 1. So in the place of x, I could put cosine theta. So I'm going to have the cosine of theta squared plus, in the place of y, I could put sine theta. So I'm going to have the sine of theta squared is equal to 1. Now in trigonometry, there's a short way of writing this. So we can write it as cos squared theta plus sine squared theta is equal to 1. Now, this is one of the most powerful identity, if not the most powerful in trig. You can basically take any angle and you plug it into this identity and it will be equal to 1. And you can also use your calculator in radians or you can use your calculator in degrees. You will still get 1. So you can pause the video, choose a random angle, and just plug it into this. This identity is so powerful that we can actually transpose this identity and basically create new identities. So I could go right ahead and say that, all right, let us transpose for the cosine squared of theta. So I could say cosine squared theta is equal to 1 minus sine squared theta. But what is so powerful about this is that 1 minus sine squared theta is actually the difference of two squares. So I could have the cosine squared of theta is equal to 1 minus sine theta into 1 plus sine theta. Right? It might become relevant to treat this as a difference of two squares at some point. Likewise, if I were to transpose a sine squared theta, this would become 1 minus the cosine squared of theta, which I can also say that sine squared theta is equal to 1 minus sine theta, 1 minus cosine theta into 1 plus the cosine of theta. Alright, so there are so many manipulations that you can have for this single identity. For our next proof, we're going to go for a very powerful equation, sine squared theta plus cos squared theta equal to 1. And we're going to divide the entire expression by cos squared theta. So I'm going to have sine squared theta over cos squared theta plus cos squared theta over cos squared theta equal 1 over cos squared theta. Now let us see what happens. Sine squared theta over cos squared theta. By laws of indices, I can write this as the sine of theta over the cosine of theta squared. Cosine squared theta over cosine squared theta. That is going to give me 1. This is equal to 1 over cosine squared theta. I can write it as 1 over the cosine of theta squared by laws of indices again. Now when I look at this, I realize that there are some familiar things happening because sine over cosine, we had proven that to be tan. So I'm going to have tan theta squared plus 1 equal 1 over cosine is secant. So I have a secant of theta squared. So let us simplify this. So this is going to give me tan squared theta plus 1 is equal to the secant squared of theta. And once again, this is an X identity that we can use. Very powerful one as well. And you can actually transpose this to get a sub-identity from it. Now we're going to go back to a very powerful identity. But this time we're going to divide out by sine squared theta. So it's going to become cosine squared theta over sine squared theta plus sine squared theta over sine squared theta equal 1 over sine squared theta. Now let's break this down. Now we know that cosine over sine from our previous proof is equal to the cotangent of theta. So I'm going to have cotangent squared theta plus 1 equal, what is 1 over sine? 1 over sine is cosecant. So 1 over sine squared would be cosecant squared theta. Once again, a very powerful identity, which we're going to employ in constructing proofs and so on later on.